8th graders, this is to help you with question 8 on CR 30. It says, determine whether the two triangles are congruent, similar, or neither. So we're going to look at triangle ABC and triangle A prime, B prime, C prime. All right, so if you look at triangle ABC, you can see right here, angle B, those are right angles. Angle C, those appear to match. Angle A is definitely the same. All right, well, I can tell you from knowing that, okay, I got to think about how to say this. Okay, angle B is congruent to angle B prime. Both are 90 degrees. This is A, and that's also A prime. A is not moving. A is not changing. So I can tell you angle A and angle A prime are at the same spot. So angle A is congruent to angle A prime. They're actually the same angle. So I know these are similar. Similar by angle. This is from a few months ago, ladies and gentlemen. Similar by angle criteria. So because B and B prime are definitely congruent, A and A prime are definitely congruent, that forces C and C prime to be congruent. If two angles in the triangles are the same, the third will be. All right. We also have to make sure our sides are in proportion. So that's what I'll show now. I'll also tell sides are in proportion. If I look at AB, if I look at side length AB, that's 2 units. Right there, that's 2 units. 2 units. If I look at A prime, B prime, that is 1, 2, 3, 4 units. So you can see to get from AB to A prime, B prime, you multiply by 2. Let's make sure the same thing happens for BC. So let's look at BC. That side length is 1, 2, 3, 4. And B prime, C prime better be twice as big, because it looks to me like it's a dilation with a scale factor of 2. So this one better be 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, 8 units. It's similar. You produce from A, B, C to A prime, B prime, C prime. You can get that by doing a dilation with the scale factor of 2. You're going to blow it up about point A. That's, if you can get the second triangle by dilating the first triangle, you know they're definitely similar. So those are similar, not congruent. All righty, Ro. Let's determine the slope of AC. So here's line segment AC. Let's get that slope. I might just do rise over run. Slope of AC would, if I just do rise over run, just to make my life easier, A to C. I'll even draw the triangle on this side if you want to get crazy. From A to C, how far am I rising? 1, 2, 3, 4. We're going up 4 units, and then we're going left 1, 2. We're going left 2 units. So we're rising 4, and then we're moving to the left 2. Because we're going up 4, that's a positive. To the left 2, that's a negative. What's a positive divided by a negative is a negative. 4 divided by 2 is 2. So the slope of AC is negative 2. How does the slope of AC compare to the slope of A prime, C prime? Well, let's just check A prime, C prime. The slope of A prime, B prime. We'll do rise over run again just for fun. So this time I could go from C prime to A prime if I want. So that means I'm going down 8 and to the right 4. Down 8 would be negative 8 over running to the right 4. Well, guess what negative 8 divided by 4 is? Negative divided by a positive is a negative. 4 divided by 2 is 2. So the slopes, I showed work to explain why those slopes will absolutely match. They're going to match because they lie on this same beautiful line. And the slope of that line will not change. Wowza. I hope that helped. I know it's not super.